In this segment, I will explain how to solve an absolute value inequalities, and I'll start with a simple one. Let's say we need to solve absolute value of x less than 7. Recall the inequality signs. So we have 4 signs of inequality. Less than, that look like an L, less than or equals to, greater than, and greater than equals to. So in step 1, I will analyze the question. So I need to solve inequality. I'm looking for the numbers that I'll substitute the x with, and all the absolute values that I will receive, the numbers on the left, will be less than 7 units. So going back to absolute value, recall what is an absolute value. According to definition, it's the distance, remember the magic word. It's the distance from 0 to those unknowns numbers we're looking for. And what do we know about those distances? They're all less than 7 units. So on the number line, I have a 0, and remember it goes from negative infinity to infinity from the left to the right. The distance between 0 and negative 7 is exactly 7 units. And the distance between 0 and 7, exactly 7 units. But our distances are less than 7 units, meaning, so distance from 0 to any of those numbers, here, or this number, or that number, or that number, all of those distances are less than 7 units. All the way to 7, but we're not including 7 because there's no equality sign. Or any distance from 0 to the right side, to this number, or that number, or that number, all the way to 7, again, not including 7. All of those distances are less than 7 units. So our numbers will be laying in between negative 7 and 7. So step 2, now we can actually unlock the gates. I call the absolute value bars the gates. We can unlock the gates and say, okay, the numbers we're looking for sitting between negative 7 and 7. Sometimes you will see statement written differently. It could say x greater than negative 7 and at the same time x less than 7. I prefer to use statement written like this because it gives me a better idea and understanding. So the numbers I'm looking for, they're sitting between negative 7 and the 7. And then the step 3, the final inequality gives the solution set from negative 7 to 7 in interval notation. So I'm using a parentheses because there's no equality sign involved. Remember, if there's an equality sign, there would be brackets, but if there's no equality sign, it would be parentheses. So any number between negative 7 and 7 will make this inequality true. And always I'll ask my students to check on the end. Pick the number from this interval, substitute the x with, and see if it works. And the easiest number, the smaller the better, the whole number, I would say, okay, let's do 1. 1 is sitting between negative 7 and 7. So how about absolute value of 1? Is it less than 7? Absolute value of 1 is 1, less than 7, check mark, we're good. You can pick few numbers. You can do one on the right side like positive, and then you can do one negative. Let's say let's pick minus 3 and substitute x with. Absolute value of negative 3 is it less than 7. Absolute value of negative 3 is 3, less than 7, check mark, true. That's the solution, and a solution gives us a true statement.